Today on Brupeg we need to deal with this oil leak. To do that we've got to pull the rudder off and strip apart this rudder post. So on Brupeg we've got a pretty standard setup for most trawlers. So they have a nozzle which basically gives them more thrust and also in our case protects the propeller from ice. The rudder, these setups get quite a bit of prop steer when you're going into tight manoeuvring conditions. So we're going to make a few modifications to the rudder to help us have better manoeuvrability at low speed, and also it makes it easier to get this rudder on and off. So on Brupeg there's a couple of things we want to do. First off, we want to make it more efficient at low speed so that we have better turning ability. With a nozzle like this, you do get quite a bit of prop steer going on when you're in marinas and sort of low speed manoeuvring positions. There's a really easy way to fix that. There's a few sort of ideas that they had in the old days, and it was basically creating drag at the back of the rudder blade. So in this case we've got a great big round bar welded onto the back. Some trawlers have 45-degree fins sort of all the way down the back edge of the rudder, and it's essentially just to create as much drag as possible at the back end of the rudder. They actually don't work. It's kind of garbage way of doing it. If you look at race yachts or aeroplanes as like a real good example of good efficiency wings and foils, what we need to do, the main issue is what's called tip vortex. So when you've got this rudder, say over 45 degrees, you've got a column of water coming out of here, it hits that blade and tries to go, some of it will go around and some of it will go up and over. You want the most amount possible going around and the least amount possible going up and over. So instead of doing all of this sort of ideas like to create the drag at the back end of the rudder, what you're better off to do is have a fin at the top and then extend the rudder blade down and have a fin at the bottom. And what that does is when the rudder is hard over, it kind of jams the water in. It can't go anywhere but sideways. And the flip side of that is it also makes it easier to get the rudder off. So at the moment when we take the rudder off Brupeg, we've got this lifting hook up the top here. You hook a forklift fork in here, you rope it up and hook a fork in there. But when you take the weight of the rudder, because this is right at the back, the rudder swings down like this. So it's a real awkward way of getting the rudder off. When you've got flat fins welded either side, you can put a fork either side of the rudder blade and just lift it and take the weight really evenly. So it's much, much easier in the future if you've got the fins to be able to get your rudder on and off. So a bit of an anatomy lesson quickly on East Coast Australian trawlers. They're limited to 400 horsepower, and that limits the size of the nets that they can drag. One of the ways that they increase the amount of thrust they get out of the back end of the propeller is by putting one of these nozzles on. So a good nozzle will give you anywhere between sort of 20 and 30% additional thrust at low speed. And given that a trawler is basically a tug, it's designed to pull as much as it can so you can get bigger and bigger nets. The more thrust you get, the better the boat is in terms of being a fishing boat. So Brupeg has a nozzle, and we're going to keep this nozzle on. So normally if it's a cruising boat, you take the nozzle off for efficiency reasons. We're actually going to keep it on there for two reasons. One, it gives us a big ring of steel around a propeller, so when we go into ice, there's a little bit more ice protection going on. And also because of the thrust that we can get out of it. So when we're in ice, if we need to ram ice or push ice apart, we've got that 20 to 30% extra thrust over a non-shielded propeller, so that it really helps us push through those ice fields.
So this is the collar that bolts together and stops the rudder from being able to travel up. If that collar's out, the rudder can sort of move up and down quite a bit, and then the top of the rudder is bolted to the bottom of the shaft with this big flange. We've also got an anode to protect corrosion. Down the bottom we've got a pin that the rudder just sits on top of, and to take the rudder off you just lift the rudder up and then back. So we're going to press on, get rid of this anode, take it off so that we can start welding the wings on so we can lift this rudder clear.
Because of timelines, we want to get the guys to forklift the rudder off before they go away on Christmas, for Christmas. So we've run out of time. We can't actually do the weld the wings to make it easy. So we're going to actually, the forklift's going to come, we're going to get these bolts off and it's going to sit under here. We're going to clamp here and that should hold it even as we lift up and take it out of this socket at the bottom and lift it in. and drag it. So we're rushing against time. They're just about to have lunch and then they're with us after lunch. So we've got to get the bolts off. That's what Dan's doing now. Oh, that came away quite easy.
Because it's covered in grease. It's like the best thing that can happen to it.
Okay, so there's a benefit to this leak.
Silver lining.
That's really good. Wow, that came away so easy. Wow, look at that.
Well, 1 of 4.
Yeah.
So what I do is I'll take them off and then I'll put one back on like that just to protect the end, because then I can whack the bottom without damaging the threads. You can see that sort of yellowy, browny, tan sort of colour stuff. That's like an anti-seize type stuff, so it gives you an idea.
Well, yeah.
Yeah, so it gives you an idea that like after however long this rudder's been on, anti-seize is a beautiful product in terms of actually just making your life easy. So now I'm going to hit the bolts out of this collar up here, and that collar is actually what stops the rudder post from being able to travel up and down.
You're going to have to cut it off.
I think we'll chop these off.
I'm liking the speed with which this is happening.
Oh, it's a lot easier.
It's so good. Woohoo!
So Jess is sitting on the phone. She's been on the phone for about like 20 minutes something already, and then she accidentally hung up. She's on hold. We're waiting for a freight company to be able to pick up a big slab of steel beside us and take it down to the other end of the country, so that we can get some bits machined up for our stabilizers. But yeah, her contribution today is having to listen to hold music for the last 20 minutes, 30 minutes, something like that.
This is the access plate that allows us to get into all of the steering system on Brupeg. We've got the 2 rams below the deck, as well as the yoke, which is the white piece of steel that goes between the 2 rams and the top of the rudder post. In order to strip all of this down and get the rudder shaft out, we need to remove the rams with these pins, and then there's a big nut on top of the rudder post. We need to crack that off and then break the taper between the yoke and the shaft.
Alright, so now that we've got this ready to go, we've undone the bolts and assembly at this end, and we've also moved the pins at the other end and pushed the rams apart, so that allows this shaft to float up and down. So when the forklift gets here, we can take this one last bolt out and push the whole lot up and then drag the rudder out.
How far you want me to go back again, or as much back as
Go
I
as
want?
much back as you can, then we'll just go up. Yeah, great.
That's it, yeah, that's as much back as I got.
Okay.
Come
Just
in
hold
and
there.
up. Yeah,
Hold there. I'm crashing down there. Okay, so go up.
It's up, yeah.
Yeah, you're right. Keep going. There we go. Might have a locating plan. If it's got a flange, I have to separate them.
Yeah, right, eh?
Yeah,
Right, yeah, you do what you gotta do.
yeah, let me check it at the top.
Rather be safe than sorry, eh? There seems to be freezing out there, Damo.
It looks like it's
It seems
holding.
to be free, the runner, like it just dropped there.
Oh,
It's hot.
Did it look like that?
Yeah. Hey, it's holding. Yeah, that looks great. Ah, okay, cool. No, it's perfect though. It's being held.
Yeah.
You can see through light through.
Sort of come down.
Yeah.
Yeah.
See the little
yeah, there's the light
Yeah.
cable thing. So yeah, come down.
come down that tiny bit and then go back.
Yeah, go like 5 mil.
Yeah.
Yeah, put it
Back.
yeah.
Then top bottom, mate.
It's been so long since I had time to think about it. Some say it's wrong to spend all your
So my back's getting pretty sore these days, so I decided to get an engine crane so that I can start lifting some of the heavier gear around. The little caster wheels will be useless on the gravel of the yard, so I'm going to put some pneumatic tyres on if I have time. These are the wheels that I bought, and I just need to figure out a way of mounting them on if I get a bit of time to do it.
So I was sort of thinking about it. I need the caster effect, but these wheels are garbage. They're not going to work in the gravel and stuff around the yard. Definitely have to roll with pneumatic tyres, etc. So what I'm thinking is actually just modifying these. It's just too narrow, so all I'm going to do is basically slice these off and weld on essentially a wider caster so it'll fit over top of that wheel, and then we can chuck these wheels on the same bolt pattern.
That's enough of the crane build. Let's get into building some rudder wings.
the mountaineer. Home to the mountaineer.
So this piece of upside down metal is the bottom of our rudder extension. So the bottom fits into this the rudder fits into this curved piece at the bottom, and then the wings get welded onto the top here. So they stick out either side of this centre line. Actually, if I go end on, what I want to do is basically weld the wings on the left and the right hand side, but I'm going to leave about a 6mm gap down the middle so I can fill that weld all the way down the centre there with a really big bead, and then I'll throw one on either side on the actual wings themselves. On the rudder, we've polished off all of the paint and anti-foul and things like that, and then I've gone through and 45 the bottom of the rudder so that we can get an equally big weld all the way along there as well.
Apologise for the wind noise if you're getting heat. I need to basically put this vertical piece on there like that, but I want to space these two apart. So the way that I'm going to do that is just with a welding rod, because then I know I've got it. I was going to do 6mm, but I don't have anything that's going to work for 6mm, so I'm just going to use a welding rod and go 3.2mm. In fact, I can put two of them, be real smart, go 6.4mm. Hey! See if it'll work, eh? And then that theoretically should fit on top really nicely, like so. Alright, so it's pretty simple. I'm just going to weld it up like that. I'll do a curve in the front to give it a nice sort of aerofoil shape, and then I'll fill this bit in at the back. I want it to extend past the back of the rudder, so both the top and the bottom fins are going to do that. So that's why there's a bit of a gap over the back here. But yeah, that's come out pretty good. I'm happy with that. So let's get this tacked together. So it's tacked together. That's the basic sort of shape at the bottom of the rudder. It obviously extends out, maybe roughly 100mm, something like that. And then we've got, at the front, I'm just going to curve it off like that, just so that pretty much no matter which direction the rudder's pointing in, we're going to have a fairly big radius at the front, just so that it doesn't bind up on anything. And then around the back, I'm just going to trim these corners off, just do like maybe a 50mm radius, something like that on the corners, just so that there's nothing too dramatic. You can't, you know, cut yourself up when you hit them or anything like that.
So now that we've got this all tacked together, you can sort of see there's 3 areas that we've put some weld in. You can see those heat marks coming through. It's 10mm thick, 10mm deep and about maybe 8mm wide, that trough. So we need to go through and essentially fill it up with metal. I'll be using my the biggest MIG wire that I can put through my machine, 1.2 wire. So yeah, this is basically 1.2, and we'll be putting it at their maximum heat settings as well. So we'll just start piling in some steel into this trough and start filling that gap up. So it's a bit of a beast of a weld. We managed to fill all of that trough up with weld. Because we put so much heat into this weld, I always suspected that these wings were going to bend, which is okay because we've welded it in a way that they bend, in this case they bent slightly up, and then when I flip it over and weld, you can sort of see the bend there. When I flip it over and weld it the other way around, it'll straighten it back out because the weld on the bottom will try and pull it the other direction.
So it's a really hot day here. It's, I don't know, mid-30s, something like that, and it's roughly middle of the day. The cable that's running out to my welder is a single-phase welder. The cable that's running out to it is getting really hot in the sun. Plus, I'm welding at maximum capacity, so the welder, everything on the welder is turned up. You know, big wire feed, big amps, everything I can is basically trying to put as much heat as I can into this steel as possible. All of that is meaning that I keep blowing the fuses, so I'm going to give the cabling and everything a chance to cool down. I can get about probably 15 minutes of solid weld out of it before I blow the fuse when it's cold, and I only get about 5 minutes when the cable's really hot. So basically turned everything off, unplugged everything, putting it in the shade and letting everything cool down, and then I'll plug it all back in and I'll be able to start welding up the other side of this fin. What I'm going to do in the meantime is actually grind all of the rudder where I'm going to start tacking on the top fins. I might even tack them on. Yeah, start that part of the process.
to the mountaineer. Home to the mountaineer.
I need to fill this gap at the back, and one of the thoughts I had was get like a piece of I don't know, 6mm round bar or something like that, stick it in there and then weld it in top and bottom. I don't actually have anything that's going to work that's in 6mm without me having to fabricate something, so I'm just going to give it a shot at filling it up with the welder. It's a bit of a gap obviously, sort of 8mm, something like that, but I'm thinking a couple of runs down either side on this side, flip it over and then fill it up completely on the other side and grind them smooth. So yeah, give that a shot. Yeah, so it worked fine. So just I flipped it over, we're gonna grind out the bottom. There's a bit of slag and rubbish and stuff that's sort of gone through as it's gone through onto the bench and stuck. It's obviously picked up a bit of rubbish from there, so I'm gonna grind that out, V it out properly, and then we'll go through and do a nice big hot weld through there, and we should be good to go with that back end of that plate.
Alright, so now that we have the one wing on, I need to mark it out on the second side and duplicate it across onto this top side of the rudder. I've decided I'm actually going to extend them out, so where I had the wings basically finishing about 100mm before the back of the rudder, I've decided that I want to extend them out to be pretty much the same profile as the bottom of fin. So you can sort of see here, if you look at them, the top one finishes quite a bit earlier. The bottom one extends about 100mm out, and the top one is 100mm short. So I need to add another 200mm to this top one to make it even with both fins.
So I need to extend out the wings on the top of the rudder. So I made a mistake. I didn't make them long enough when I was cutting out the 10mm plate. They don't have to be 10mm all the way to the back end of the wings. They can be a bit smaller when you get right to the back end of the wings. I don't have any more 10mm plate, or not enough to actually do an extension on the back. I do have some, I think this is 6 or 8mm, something like probably 6mm. I'm going to cut this circle out here, and then that'll slide down the top of the rudder. I'll weld this on. And then we can trim the back end to suit. So my extension on the back end of these is going to be slightly thinner, but yeah, there's plenty of strength, so I'm not too stressed about that. It's not going like opposite any water flow or anything like that. It's just stopping the water from curling up and going out right on the back end of the rudder, so we shouldn't have too much drama with this.
So now we've got the rudder welded together, it's time to rip the shaft out so we can figure out how to fix the bearings.
So before we rip this rudder shaft apart, I need to figure out if we've got an alignment problem. So Brupeg is chewing out bearings on the rudder. So there's 3 bearings, 2 at the top and 1 right at the very bottom. And the middle bearing is getting chewed out as well as the bottom bearing.
So you can see that shaft there, you can see that wear like around that side there where there's no wear, that's basically where the bearing's not touching it. But then on the forward side, you can see all of that shiny stuff. That's basically, I don't know, grit and whatever else. In this case, probably misalignment. But it's yeah, obviously been wearing out that shaft for a wee while. The bearing itself does the equivalent sort of wear, so I'll show you the bearing now. So these bearings are made of a stuff called ralloy. It's a proprietary material, but you can sort of see inside there's fibre and so on, but it's a soft bearing that can take quite a high loading, and it's also self-lubricating. Because we can't put any grease down the bottom, it's basically the seawater that does the lubrication, but obviously you also get grit and whatever else gets thrown up by propeller. So they do take a bit of a hiding, and you can see this one is wafer thin over here and it's quite thick over here. This probably would have been the original thickness, and then this is whatever it's worn down to, so you can sort of see it's worn in an oval. But yeah, we'll get a new one of those made.
So this is the little laser level thingy that I bought. Has regular levels, but it also has a laser, so you can, where are we? There you go, you can sort of see that, and then it also has a pointer. There we go, just like what you annoy your cat with. So what we need to do is figure out between that pin there on the bottom and that flange at the top where the misalignment is. So I don't know quite how I'll do it yet. I'll have a few shots at it, see how I can figure it out.
Okay, so after much measurement, swearing and deliberation with my engineering team, we've decided we're going to cut this pin off completely. We're going to make a new one and weld a new one on. It's going to be easier than trying to muck around and straighten this one up, mainly because we're straightening up a pin that has a whole bunch of wear on the back of it. This flange and this shaft and everything up here is all good. We're going to basically just use whatever alignment that is. We're going to put new bearings in, use whatever alignment that is, and then weld it to suit. This pin will be welded to suit, so we'll use laser levels to align it. We don't necessarily think when they put this in originally that they had that level of accuracy, so it's possible that this was put in original like this and then they just replaced the bearings every 5 years or however long they got out of it. What we need to do down here on the rudder, just down on the bottom of the rudder itself, that ralloy bearing there we need to strip out, measure the OD of the shaft, and then measure what's left of the original bearing at the back where there's no real wear on it. and then we're going to machine a new one of those up as well. Okay, so now that we've got our little plan that we made for the rudder pin and the bearing and so on that goes at the bottom, I'm good to now pull the shaft out of the rudder. So what I'm going to do is carry on with my grinding. I've got to make some steel wedges, and then we sledgehammer the crap out of these wedges in between the shaft flange and the bottom of the boat, and that hopefully will pull the yoke off at the top. I've been calling it the T-bar, but it's actually a yoke, so it's a tapered fitting potentially on this shaft that we need to crack off. So we need to load up heaps of pressure using our steel wedges, and then we give the yoke a big wallop with the sledgehammer, and that should pop it off. Oh, you fucking beauty. The design of it's pretty simple. So you've got a big nut that's welded onto a flange, and then that, I've obviously unscrewed this, but when you take that off, that nut presses down on this surface here, the one that's covered in the silver anti-seize, and if you have a look straight down that shaft, you can sort of see all the way around here, that's the outside diameter of the rudder shaft, and then right down in here you can see that there's a square pin machined in. So that's what stops the shaft from being able to rotate on this piece of 1-inch thick steel. So this steel is welded to this flange down below. I'll just see if I can spin the camera around and show you. So this piece of steel here rubs on this, which is a wear plate, so you can sort of see that plate there is loose, and that's basically just a plate that gets covered in grease and spins between them. It acts like a big washer, and then this piece of steel here is basically welded into the boat. So the boat is sandwiched between the top of the rudder post and the boat, and that wear plate there stops them from being able to move. So all of this assembly stops the rudder from being able to go down. In order to get this flange down, I need to make some steel wedges. So I got a bit of old 16mm thick, 16 by 100mm thick flat bar. I'm gonna cut some wedges out of this, so they're gonna be quite long and very fine, so that we can keep whacking in and get lots and lots of pressure on. Basically what I want to do is load that shaft up with heaps of pressure, and then go up the top where we think that there's a taper in there and give it a good belt with the hammer. Got a sledgehammer to do that, and then hopefully it'll basically crack that taper so that it goes out of round for a split second. Once that happens, it'll just force that shaft away from itself. Alright, I'm gonna go give it a whack at the top.
One more bang should get this.
So after all of that, this is what we're left with. So this is the top end of the rudder shaft. And you can see those sort of faint lines going around the shaft. That's basically wear. So it's a wee bit hard to see, but there's quite a bit of wear. So we've polished the shaft up so it doesn't look as bad as what it potentially could have. But yeah, there's still, I don't know, probably a good millimetre of wear in that shaft there that we need to take out.
So taking the bottom bearing out, we basically just put a pipe down on top of the bearing and just belt the crap out of it until it comes out.
Come out about an inch. Right, more whacking. Bottom bearing out, that's the little puller that we used, turned into more of a belter. So we'll give this a clean up. I'll plasma in the big hole in it. We'll put the threaded rod in so that we can do the top bearing, because I need to pull that up, so I'm not going to be able to physically hit that up. So let's get into this one. Bearing. Yeah. So that's the top bearing there. So machine up a new one of those.
So with all the parts that we pulled out of the rudder stock, this is our little care package that we're sending down to John so he can machine a new shaft and a set of bearings.
So we learned a lot with this episode. The shaft is out. We've got 3 bearings in the shaft, 2 at the top and a rudder pintle bearing right at the very bottom, or a bush. One of the things that we found was the bush itself. When they welded the bush on, it's very hard to get it perfectly aligned. They didn't have laser levels when they built this boat, so the bush, the pin is welded slightly on an angle. So when you get to the top of the rudder, it's 50 mil out off to one side. So that's chewing out the bottom pintle bearing, and it's also chewing out the one of the bearings up in the shaft here. So a couple of issues. The old bearings had asbestos in them. They were kind of a harder bearing than what we're going to be putting in. And one of the issues with that is we believe it's worn out the shaft a little bit. So the shaft is 316 stainless, and it had maybe 1.5 mil of wear. So we could have ground, say, 1.5 mil or 60 thou off that shaft and cleaned up that wear. But then we wouldn't have had enough on the taper at the very top. We wouldn't have had enough left on that taper to bolt the yoke back on. So we pretty much, the only option we had was to actually build a new shaft. So one of our Patreons, John in Victoria, is machining up a new shaft. He's also machining up the 2 bearings at the top and the bush for the pin at the bottom. And he's also making a pin that goes, a new stainless pin that goes in the bottom, because there's a bit of wear on that pin from the old misalignment. The bearing material that we're going to be using is a oil impregnated nylon. We can't use the old material being having asbestos in it, so the nylon bearings that we're going to be using are pretty awesome. The specs on them are pretty amazing. So when we've got those bearings up, I'll do a bit of a talk about them and show you some of the specs. As I was saying, John's doing the machining for this bearings and the shaft and everything. He's also machining up the hinges for our stabilizers. The old stainless steel 316 stainless shaft that came out of here is going to be chopped up and used as pins for the hinges, so waste not, want not. And just to sort of put some of this into perspective, John's going to be driving up from the bottom end of Australia right up to the top, so that's a huge haul. It's a couple of days of solid driving. Really looking forward to seeing him. But now it's time for a bit of fun. Time to see if this thing works. Good enough.
Hey, I heard you want to leave this place where we grew up. This old town, just put it all behind.